Good morning. Welcome to today's physics lesson. What we're going to do today, very exciting stuff. We are going to use Kepler's third law to calculate some information about planets. Here's what you will need for the lesson. You will need your textbook. You will need a calculator, and you'll need your notes. So take a moment, pause the video, and go get all that stuff. All right. Today's lesson, we are going to, I have to switch between a couple of things. We're going to call this, today is April, Kepler's, we'll call it using Kepler's third law. So today we're going to do some math, we're going to do some calculations. Get excited, here we go. So Kepler's third law states that the time that it takes a planet to revolve in a ratio squared is equal to the distance that object is cubed. So you're lucky someone already, derived this formula and it works. It works in comparing any body in space. So when you think about it, that equation looks kind of simple and it works for any planet in space. I apologize. I have to keep pausing the video. I usually bribe my son with gummy bears to remain quiet while I'm recording these. So if you hear him, just ignore it. So what's going to be your friend in this chapter is the chart on page 178. What I would recommend doing is last year, my students, they took a picture of it and they made it their favorite or, made it really easy to find on their phone because you're going to need to reference that chart throughout the lesson. And I'm going to try something different. I'm going to try to, no, I don't want to create a new board. Give me a second. I want to insert a picture. There we go. Insert. And if this works, great. If it doesn't, let's see here. Downloads. Chart. Let's insert. All right, apparently I had to upgrade to Pro, so I will just reference that chart along with you guys. So here, maybe give me one more second. Let's download. I downloaded the chart. All right, let's not do that. Okay. So anyway, just open it up to that chart. And here's how these problems work. You're gonna have to get used to how they sound. So it'll say calculate. Let's calculate Mars's orbital period using Earth days. Tom just brought a Lego over. That's the noise you heard. All right, so calculate Mars's orbital period using Earth days. And when you do these videos, you can pause them at any time to keep up. So sometimes I'll pause and wait for you. Sometimes you're going to have to pause the video on your own. Using these problems, the 5-step problem-solving method comes in pretty handy. So we're talking about Mars. And it says, calculate Mars's orbital period. Well, the variable for period is capital T, and we're talking about Mars. So I write it as T sub m. That's what we're looking for. And it says using Earth days. So we're comparing it to Earth. And what is the orbital period in days? How long does it take the Earth to go around the sun? If it's looking for days, we're going to use 365 days. Yes, I know there's some, decimal places behind it, or, it's 364 point, but we're using 365 days. All right. The other variables that we need to find are R sub m and R sub e. And if you sketch the problem out, here's the sun. Going to draw my ellipse. And this is the orbital period of Earth. But we want to find out, well, where is Mars? So Mars is a little bit closer. So, Mars is orbiting somewhere in here. Okay, so if you haven't found the chart, it says Table 8-1, Planetary Data. And it looks like this. And we are going to use the third column. So we're going to use the one that says mean distance from the sun, because we're talking about how far away these planets are from the sun. So I go to Mars and I go all the way over, and Mars is 2.28 times 10 to the 11th. So the radius, the orbital radius, we're not talking about the distance of the planet. We're talking about its orbital distance from the sun. So the first column says average radius. That's just how far across the planet is. We don't want that. We want the mean distance from the sun. So Mars is 2.28 times 10 to the 11th. And you know what? To get in the good habit, I'm going to put it in parentheses, because scientific notation in your calculator always goes in parentheses. All right, find Earth on the chart and Earth's mean distance from the sun. All right, so how far is the Earth from the sun? 1.5 times 10 to the 11th meter. Oh my gosh, I'm so embarrassed. Mars is out here, my bad. It's early in the morning. All right, and we're going to put this in parentheses. Okay, now we're going to use Kepler's third law. And when we do this, we are going to put what we're solving for, those variables are going to go up top. So we're looking for Mars. So T sub m is up top. T sub e will be on the bottom. So if Mars is up top on this side, Mars will be up top on this side. Don't forget about the squares. Don't forget about the cubes. There's a lot of stuff that you're going to have to keep track of in this problem. All right. So if you need to pause and catch up, go ahead and do that. All right. In plugging in, I'm leaving this as T sub m. And the time it took the Earth was 365 days. That quantity squared equals, you have to have large parentheses for that side. And then you need to also have additional parentheses around the radiuses. It's 11. And where students usually go wrong is they usually forget a set of parentheses. All right. And so all I did is I plugged R sub m in up top and R sub e in the bottom. All right. We're looking for T sub m. And right now, T sub m is inside parentheses. And what we have to do to get rid of it is we have to distribute. So what we have to do is we have to distribute the square. And once I distribute the square, I can get rid of the parentheses. So I have t sub m squared. So I just distribute it to the top and the bottom. And now that I have, oops, I'm sorry, that's not cubed. If anyone caught that, that's squared. And now that I have distributed that square, now I can move the 365 squared around. That's equal to this side, this whole mess of a side. So the radius, or the distance of Mars, don't forget parentheses, over the distance of Earth. That quantity is cubed. Okay. It looks like a lot because there are a lot of numbers on the right side. But if we focus on the variable that we're solving for, so we're solving for t sub m, how am I going to get it alone? Well, I got to get rid of this down here. And I get rid of it by multiplying it on both sides. Okay, so this is where you're going to need your calculator. So we have t sub m squared equals, I'm going to plug this whole thing in. And I'm going to plug it in exactly as it's written. So I'm going to do parenthesis. Actually, I'm going to plug it in two parts. I'll plug in this whole thing. All right, so I'm going to plug in that, and I get, so big parenthesis, and I'm going to plug in this little parenthesis, 2.28 times 10 to the 11th, close this parenthesis, divide by parenthesis, 1.5 times 10 to the 11th, close this parenthesis, close that parenthesis, to the third. All right. And when I did that, I got 3.511,808. I'm going to plug it in again just to make sure I did it right, because I don't have any of you guys, giving me verbal feedback of, hey, that's what I got, or no, I didn't get that. So the big parenthesis, 2.28 times 10 to the 11th, close the parenthesis, division sign, open parenthesis, 1.5 times 10 to the 11th, close it, close the big one, to the third power. All right, and I still got the same thing. Times, don't forget about this guy, 365 squared. So go ahead and do that. Plug that in. It's a square. So take it times 365 squared. All right, so now I get a pretty large number. I get 467,860.6208. And remember that this is squared, so I have to take the square root. All right, so take the square root and let's round it to a whole number. So the orbital period of Mars is 684. What's our label? Well, in the beginning, we were comparing it to Earth days. So it takes Mars 684 days to orbit the sun. So, it's double our orbit almost, all right? So I'm going to continue the problems on a separate video. Remember, you can always pause and catch up.